This video will cover Cramer's rule for a system of 3 equations and 3 unknowns, or 3 by 3 problems. Again, this is the exact same rule as previously, with the exception of now there are 3 variables, which means there are 3 equations and 3 variables, which means the determinants are 3 by 3 determinants instead of 2 by 2 determinants. So here we have a system of 3 equations and 3 unknowns written in standard form. So ax plus by plus cz equals j, dx plus ey plus fz equals k, gx plus hy plus iz equals l. And I know you're not supposed to use I, j, k, and e for variables, but that's okay. A through l are going to be real numbers. What Cramer discovered is that we can use determinants, again, just like we did for 2 by 2, to find these values. The bottom determinant for each of these quotients would be the coefficient matrix. So again, that's the coefficients from x, a, d, and g in the first column. Coefficients from y, b, e, and h in the second column. And the coefficients from z, c, f, and I in the third column. And that's going to be the same matrix that we put on the bottom of all 3 fractions, x, y, and z. Up top, just like we did for the 2 by 2 matrix, we took for x the x column out and replaced it with the answers. So a, d, and j are going to be removed and replaced with j, k, and l. The b column, b, e, h, and the the y column, b, e, and h, and the z column, c, f, and I, would be intact. So then we would carry out those 2 3 by 3 matrices, divide, and we would have our x value. Similarly for y, the bottom determinant is again the coefficient matrix, so it's exactly the same as it was for x. X column, y column, and z column. And then on top, the x column would stay the same. The y column would be replaced with the answers, j, k, and l. And the z column would be the same. Then we have a third one we have to do for z. Same deal. The bottom is going to be our coefficient matrix, so our x coefficients in the first column, our y coefficients in the second column, and our z coefficients in the third column. And when we go to the top, the x and the y columns will be intact, and the z column will be replaced with the answers j, k, and l. So this is a significant amount of work, but it's really not that bad. It's 4 3 by 3 determinants because we have to do the top determinant for each of these fractions, and we have to do the bottom determinant 1 time. Once we know that value, we don't need to do it again. So here's an example, and actually this example is going to be a short example because it actually indicates a special case. Here we have a system of equations, 3 equations and 3 unknowns, and we're asked to solve it using Cramer's rule. So we would start off by finding x. Now again, that's 2 3 by 3 determinants. The bottom determinant would be the coefficient matrix. So the x coefficients are 1, 3, and 2. The y coefficients are 1, 3, and 2. 1, 3, and 2. And the z coefficients are -1, 1, and -2. Now, up top, the y column and the z column are the same. But the x column is removed and replaced with the answers. Now, in this case, it turns out that the answers are the same numbers, which is extremely rare. Now, for those of you that don't remember how we do this, when we are doing a 3 by 3 determinant, we have been using the row copying method, where we copy the first 2 columns of the matrix because we have 3 positive diagonals that we have to multiply together and add up. Those 3 start off positive. And 3 negative diagonals that we have to multiply together and subtract. Okay? This 3 is kind of hard to see now, so I'm going to write it in a different color so we can see it. Okay? I'm just going to go over all these numbers so that the numbers can be seen here. Okay. So we go through and we multiply that out. That's 1 times 3 times negative 2, which is negative 6, 1 times 3 times negative 2, plus 1 times 1 times 2, which is 2, plus negative 1 times 3 times 2, which is negative 6, minus 2 times 3 times negative 1, which is negative 6, minus 2 times 1 times 1, which is 2, minus negative 2 times 3 times 1, which is negative 6. Then we're going to plug that in the calculator. Keep in mind that these double negatives will turn into plus signs. We add those up. So negative 6 plus 2 minus 6, because plus negative 6 is really minus 6, plus 6 minus 2 plus 6. That is 0. Now, ladies and gentlemen, it doesn't take a genius to follow that the same exact matrix is also on the bottom. But again, we would do another 2 by 2 matrix, which has 3 downward diagonals that are positive to start, and 3 negative diagonals, which go up, that we would subtract to start. But that's the exact same sum, which means it's also 0. Same exact work. Now, folks, this should instantly for an Algebra 2 student, show us that we have a problem. We are not allowed to divide by 0. Which means that x is undefined. If x is undefined, how do you think we answer this question? Well, if we can't find x, I'm willing to bet that the way we should answer is by saying no solution. Now let's do one that actually works. So here's another system. This one is actually going to work out. So x will be given by the quotient of a pair of 3 by 3 determinants. The bottom determinant is going to be our coefficient matrix. The top matrix, we will replace the first column, 1, 2, and 4, with our answers, negative 4, 15, and 19. The other numbers in the y column and the z column will remain the same. Copy those first 2 columns. And then we're going to multiply this out. So again, we've got 3 downward diagonals that start off being positive, and 3 upward diagonals that start off being negative. And they may not stay that way. They may change. Okay? I'm going to put these numbers back on top again because the highlighter kind of obscures it a little bit. There we go. Now they can all be seen. So, we'll multiply this downward here. That's negative 4 times 3 times negative 1, which is 12, plus negative 3 times negative 1 times 19, which is 57. 3 times 15 times negative 3 is negative 135. Then we have our upward diagonals, which start off as minuses. So minus 19 times 3 times 3, which is 171, minus negative 3 times negative 1 times negative 4 would be negative 12, minus negative 1 times 15 times negative 3 would be 45. You can go ahead if you want at this point and add those up. So 12 plus 57 minus 135 minus 171 plus 12 minus 45 is negative 270. On the bottom, we copy those first 2 columns. We have 3 positive diagonals, so there's 1, 2, 3 that we're going to multiply together. That's 1 times 3 times negative 1 is negative 3, plus negative 3 times negative 1 times 4, which is 12, plus 3 times 2 times negative 3, which is negative 18. Then we have our 3 negative diagonals to multiply together and subtract. So again, some of those get a little obscured. That's a 3, that's a 3, that's a negative 1, that's a 1, that's a 2. Okay. 4 times 3 times 3 would be minus 36. Negative 3 times negative 1 times 1 is minus 3. Negative 1 times 2 times negative 3 is minus 6. Plug that into the calculator to see what we've got. That is negative 54. And then divide. Negative 270 divided by negative 54 tells us that x equals 5. Now we're not going to have room on this page to do all three of these, so I will do z on the next page. But y would be next. Again, we already know that the bottom determinant is the same determinant. 1, 2, 4, negative 3, 3, negative 3, and 3, negative 1, negative 1. We do not need to redo that work to know that that is negative 54. So there's no reason to redo that work. We can simply take the number from the bottom of the x fraction and it becomes the bottom of our other two fractions. Up top, the y column will be intact, 1, 2, 4. I'm sorry, the x column will be intact. The y column will be removed and replaced with our answers, negative 4, 15, and 19. And the z column will be intact, 3, negative 1, negative 1. So we copy those first two columns, 1, 2, 4, and negative 4, 15, 19. And we carry out our determinant process, which again, we're going to have 3 positive diagonals that we multiply out. So that's negative 15, 1 times 15 times negative 1, plus negative 4 times negative 1 times 4, which is 16, plus 3 times 2 times 19, which is 114. And then we have our 3 negative diagonals, 1, 2, 3, that we are going to subtract. And again, I'm just going to clean it up a little bit so we can make sure we can read those numbers. Okay, so that's 4 times 15 times 3, so minus 180. 19 times negative 1 times 1 would be minus negative 19, which becomes plus 19. Negative 1 times 2 times negative 4 would be minus 8. So negative 15 plus 16 plus 114 minus 180 plus 19 minus 8 is negative 54. So we have negative 54 divided by negative 54, which is 1, which means y equals 1. Okay, so x equals 5, y equals 1. Now we need to move to z. Now again, we have I might have to flip back and forth a little while to do this here. Z is yet another pair of 3 by 3 determinants. That bottom determinant, though, we already know. The first column is our x coordinates, or our x coefficients, 1, 2, and 4. The second is the y. The third is the z. So that's 1, 2, 4 in the first column. Come on. Struggling a little bit here. Give it a minute. There we go. Okay. 1, 2. Oop, too far. Come on, computer. You're killing me here. All right. 1, 2, 4 in the first column. The y is going to be the same as it was for x and z. Negative 3, 3, negative 3. And the z is going to be the same as it was in the first two. 3, negative 1, negative 1. Now those first two columns up top are the same. So we can just copy those up there now. The z column, however, will be replaced with our answers, which are negative 4, 15, and 19. So negative 4, 15, and 19. Now again, we already know that that bottom is equal to negative 54, so there's no reason to reinvent the wheel here. Okay? Up top, we're going to copy those first two columns, 1, 2, 4, and negative 3, 3, negative 3, and carry out our determinant process. So I know this video is getting a little lengthy, and I appreciate you staying with me. We've got 3 positive diagonals to multiply out. 1 times 3 times 19 is 57, plus negative 3 times 15 times 4, which is negative 180, plus negative 4 times 2 times negative 3, which is 24, minus, and we've got our 3 upward diagonals, and I kind of missed a little bit, so let me try that again. 1, 2, 3 upward diagonals that we need to multiply out and subtract. All right, so that's 4 times 3 times negative 4, which would be minus negative 48, which would become plus 48, minus 3 times 15 times 1, which would become plus 45, and minus 19 times 2 times negative 3, which would be plus 114. Feed that to the calculator. 57 minus 180 plus 24 plus 48 plus 45 plus 114 would be 108. Divide by negative 54 is negative 2. So z equals negative 2. Now folks, we now know x, y, and z. So we should be writing our answer as an ordered triple. X is 5, y is 1. X is 5, y is 1, z is negative 2. So we should write our answer as 5, 1, negative 2. Thank you for your time and attention. Next video will cover augmented matrices.